When I was little, I tried to grow rocks in a box, putting water on them, and that's about as far as geology went for me. But I like it now. It's something I grew accustomed to. The oil field is definitely where I want to stay for the rest of my life.
Let me run out there.
Right now, we're drilling with water-based mud. This is how the rocks are coming up. This is a piece of Lower Marcellus, probably from an outcrop. And it's shale. It's very dark gray to black. This is where we find our gas. My name is Megan Honeyford, born and raised just outside Montrose, PA. I graduated high school in 2011, and I started working for just local companies, a car wash, a restaurant. I called the supervisor at the time and asked for a job, and I started as a sample catcher and just kind of kept working my way up.
Megan works on a rig in Susquehanna County, Pennsylvania, one of the earliest epicenters of a new kind of natural gas drilling. Across the nation and the world, two techniques are coming together to make it happen: horizontal drilling and hydraulic fracturing, also known as fracking. In states like Texas, Pennsylvania, Louisiana, Ohio, and Colorado, drilling rigs and wells are popping up at an unprecedented pace. They're changing people's lives and America's energy landscape.
It is the natural gas boom we're seeing. We're going after natural gas that I think the industry has known existed for a long time but didn't have an economic way to extract it.
We've established that there's natural gas reserves in the U.S. that might sustain our natural gas use for the next 100 years, and this is a fundamental change in our energy outlook, our domestic energy outlook. That is important from a job standpoint, from an energy security standpoint, and from a purely, local financial standpoint.
Hydraulic fracturing was developed in the late 1940s. It's a technique that replaced the use of nitroglycerin and dynamite to essentially stimulate a well. So hydraulic fracturing is essentially the creation of pressure through water that is going to crack open rock. Is simply opening up fractures in the ground. So we utilize hydraulic fracturing to go in to all the little nooks and crannies and crevices, sort of like Swiss cheese, how you have pockets inside the Swiss cheese. The hydraulic fracturing is simply a method or a means to open those up and connect them together to allow the gas to flow back to the well.
Around Pennsylvania, down by Pittsburgh, you never make the kind of money that I'm making now. Unless you're a doctor or a lawyer. I've been able to buy my kids stuff that I'd never be able to buy them before. Be able to have a nicer house, nicer cars.
One industry study put the jobs number at 600,000 in 2011 alone. That includes direct jobs like those on rigs, indirect jobs like those that supply equipment, and induced jobs like those at hotels and restaurants in gas towns.
Horizontal drilling was invented sometime in the late 60s to early 70s. Well, the secret behind it is it's actually quite a simple process. See, this metal pipe right here has some natural flexibility to it. So by putting this slightly bent piece of pipe on the front and putting a drill bit on the front of it, what we essentially do is start turning the drill bit, if you can imagine my hand as the drill bit, out about 10 degrees every 100 feet. So the whole process takes about a quarter of a mile. It's a slow and simple process, but this allows us to turn the pipe without bending this pipe. Cabot has some existing plays or development in Oklahoma, Texas, and West Virginia. And most recently we entered Susquehanna County in 2005 to develop the Marcellus Shale. If you were to look at a map of our holdings, it would cover, I'd say, 70 to 80% of Susquehanna County's recoverable land.
Water started turning. I started doing all the drilling around here. And that's when the water started turning.
The process that brings the gas to the surface raises concerns about risks, both to the environment and human health. Leaking pipes could pollute the air with raw methane and contribute to global warming. Fracking uses millions of gallons of fresh water per well. Most of that water cannot currently be cleaned or reused. The issue most often raised is contamination of drinking water. Some are worried about the chemicals injected in the fracking process. Others are concerned that fracking could enable methane, heavy metals, or radioactive elements that are already present in the ground to make their way into drinking water.
DEP came in and started testing the water. When they tested the water, the test results come back with 27 chemicals that are in the water now. Let's see, uranium-238, 235, 236, uranium-234, you got barium, strontium, and I mean, there's the list right down to arsenic. I mean, it just goes on and on.
Ray's neighbors in Pennsylvania were among the first to sound an alarm late last decade when they say they noticed changes in their water, or in some cases, fracking fluid spills on their land. State and federal officials did find elevated levels of methane and a few other chemicals in several Dimock area water wells, but they concluded that the water is safe to drink with filtering.
Going to Montrose, Pennsylvania to get water because all our water wells down in Dimock are contaminated by the gas industry.
Ray and some of his friends bought a special truck to haul non-potable water from the next town. It's water for showering, laundry, and flushing toilets. They buy their drinking water.
Yeah, she's frozen solid. Everything's frozen solid.
One of the reasons Ray drives to Montrose for water is the level of methane in his own water. Methane makes up the bulk of natural gas. It's not toxic, but it is explosive. Due to the area's geology, methane has been known to seep into water wells and local springs for generations.
We know, based on our baseline testing here in Susquehanna County, that 70% of the water wells in this area have methane in it.
Most of the places that you hear about this, it's like he says, they've always had bad water. They've never had good water.
Duke University researchers, however, found an average of 17 times higher methane levels in water wells near gas drilling compared with those farther away. And the chemical fingerprint of the gas showed that it came from a deep formation, likely the Marcellus. A Cabot Oil and Gas report refuted both claims. It said the amount of methane in water wells depends on whether they're in a valley or not, rather than how close they are to gas wells. And about that chemical fingerprint, Cabot says it could also implicate a rock formation just above the Marcellus, one that's already connected to aquifers. The Environmental Protection Agency is looking into methane migration as part of a major investigation on whether fracking affects drinking water. It's due out in 2014. In 2010, gas companies paid $21 billion in bonuses and royalties to American landowners to lease their mineral rights. Most people are happy to cash their checks, and they support the gas exploration on their property.
The arrangement we have with Carrizo is there'll be 8 wells on that and another 5 or 6 on the neighbors, and there will be one more pad somewhere else, but all of our land will be produced. I mean, we're putting a boy through college right now that would be a lot tougher if we didn't. We were able to purchase some machinery and a couple new pickup trucks.
For those farmers who decide to invest the money back into their operations, the payments often make a difference between staying afloat or losing their farm.
Years ago, you know, when you drove down the road, especially if it was really, really early in the morning, you'd see the barn lights on, and it would be every quarter mile. And now, if you drive somewhere early in the morning, you can go from one end of the county to the other, and there's not a whole lot of barn lights on because the farms aren't, you know, there's not a whole lot of dairy farmers left local. Some of those farms, they're able now to keep the farm in one chunk, so it's definitely going to be a good thing.
In a broader sense, the shale gas boom is enabling the nation to produce more energy at home. That means the U.S. can rely less on foreign sources.
Now with the Marcellus Shale and these other plays in our backyard, literally, we are producing the gas using American labor. We are moving it to market using American infrastructure, and then we have American consumers using the commodity that we're producing. It's cheaper because we don't have to import it from so far away. It's supplying so many different businesses with feedstocks for the plastics industry, for the fertilizer industry, for manufacturing, building, etc.
Methane is one potential source of drinking water pollution. Fracking fluid is another. Unlike naturally occurring methane, fracking fluid is pumped down the well as part of the gas extraction process. It contains mostly water, with less than 1% of sand and chemicals. Some of the chemicals you can find in your kitchen, like salt, vinegar, and citric acid. But others are toxic.
I do love fracking. It's vital. I think there's a dichotomy that people think if you're in the oil and gas industry, you don't care about the environment. I think it's just the opposite. It has never contaminated drinking water. Hydraulic fracturing has never been a single documented case of groundwater contamination.
The EPA, the DEP in this area have studied it. We have universities studying it. We have independent contractors of ours, laboratories studying it, and it all proves the same thing, that the water is the same as it is before, as it is after, and that our hydraulic fracturing operation is safe and it's not impacting the local aquifers.
Bought this house in 1986, and it was like having a piece of heaven on earth. I had no idea that air could smell wonderful until I moved here.
Rebecca Roeder lives in Susquehanna County, Pennsylvania.
You know, my water is still okay, but I know where a lot of the homes are with impacts, and there's at least 15, 20 homes over in the Lenox area with impacted water. They never got water replacement. One of them is a dairy farmer. The water was impacted 3 years ago, but they were in debt. They had no choice. They kept milking and sending the milk to market. It used to be a nice private country place, and now it's like, you know, here's another truck coming down the road. So that was my Christmas card.
To frack a deep shale well, companies pump in 5 to 7 million gallons of fracking fluid. Between 20 and 70% of that flows back up the well to the surface. The rest is believed to stay deep underground. Whether it does, and whether it always will, are open questions.
You might have issues of timescale. There might be years or tens of years before something might show up. Historically, there have been, industrial processes that have led to water contamination, and we didn't think there was a problem, and then there turned out to be one.
Gas is justified because we get more energy yield per unit of carbon combusted with gas than we do with either oil or coal. So one of the issues is that, well, if to the extent we substitute gas for oil or coal, especially in generating power, we have the potential for less CO2 emissions per kilowatt produced. The other end of that spectrum, however, is that we could produce energy with no CO2 produced. And so the benchmarks are on both sides. We could produce energy with all the emerging technologies in wind, solar, possibly biomass. So in the very bigger picture, some would view this as yet another source of fossil fuel that we're going to combust and inject into the atmosphere.
We need it all. Renewables aren't there yet, cost-effective wise, and even they themselves, the solar, the winds, and you name it, geothermal, have impacts on our environment and have impacts on landowners and stakeholders that are undesirable. I mean, people say they want wind, but they oftentimes won't put one in their own backyard. There is no magic bullet. We're not going to fuel our future on unicorns and rainbows.
Fracking is exempt from federal laws that protect drinking water, and despite its rapid growth, there's still a lot we don't know about its impacts.
I think the question still remains whether or not hydrofracking is a big deal, right? As a scientist, I don't come in with a preconceived notion that it is or is not a problem. And I think that the reason we as a society need to focus on this issue in a very rigorous and balanced way is that we might be better informed and able to answer the question about whether or not hydraulic fracturing is something we need to be concerned about.
Across the country, researchers like Brian Ellis are working to understand the effects of shale gas development and to make it as safe and clean as possible.
Your microporosity and potentially some organic matter if we can get in there. Okay, you just injected a bunch of fluids in the subsurface and you cracked a rock, now what? And that's where I come in and I try to understand what happens, how those chemical additives might impact the leaching of trace metals and other material from the shale formations.
Heavy metals like arsenic and mercury, and radioactive elements like radium are naturally occurring in the shale, more than a mile underground. Fracking fluid could draw them out. The EPA is looking into whether they could end up in drinking water.
If you think about this from an engineering standpoint, an application to better understanding this might be we could maybe design or tweak the fracking fluid mixture such that we would maybe reduce arsenic that is leached from these formations.
For these absorption experiments, we need liquid nitrogen.
Elsewhere at the University of Michigan, Johannes Schwank hopes to study fracking fluids from a chemical engineering standpoint.
We want to develop a better understanding of what happens underground when these rock formations are fractured, and how do the gases desorb or diffuse out of the pore space. Are there any chemical reactions that the fracking fluids will undergo deep underground, and if so, do we have to be concerned about the new chemical compounds that might be forming, and so on. And these are things where there is not a lot known.
Schwank and Ellis are both involved in a major U of M Graham Institute study that looks at fracking issues as they pertain to the state of Michigan. Michigan is one of 28 states with potentially significant shale gas reserves. The study team includes U of M researchers, industry representatives, environmental organizations, and state regulators.
One of the unique issues related to hydraulic fracturing is that I think, especially in states like Michigan, we're almost able to get ahead of the curve in some ways. The integrated assessment that the Graham Institute is coordinating brings together faculty from engineering, economics, law, public health, evolutionary biology. So we have sort of environment, engineering, public perception, the socio-economic impacts. The goal, I believe, is to help understand the broader impacts of hydraulic fracturing within the state. And if it were to happen at a larger scale, what does that mean with regard to risk of contamination? What does it mean with regard to impact on local communities?
The team's work could inform state officials as they consider new fracking policies. Already in Michigan, a grassroots group is gathering signatures for a ballot measure to ban horizontal fracking. Gas and oil companies have been actively leasing mineral rights.
The X's, it's pretty much all the land that was auctioned off at the Allegan State Game Area.
Karen Fafelsky is part of a group that's suing the state over leases of public land.
Already we had quite a few neighbors that had leased, the ones next door, and then some down the road had already leased. I've never been an activist. In fact, I participated in my first rally in October. It was, at 60 years old, I'm carrying a sign. It was kind of funny on one hand, but it was certainly educational. I don't want this land to be ruined. I want our water to stay good. I didn't want to cry. The idea that they can destroy our water and our forest on our state land, it's just overwhelming to me. What we've been able to appreciate, I want our kids to see. I want our grandkids to see.
The issue has multiple dimensions, everything from what can we do now, this year, to make sure the environment isn't compromised, to make sure that fragmentation is minimized, to make sure that we keep toxic chemicals out of the water, to make sure that the wastewater is treated. If we're going to extract resources, whether it's natural gas or mining hard metals, we really need to do it right here, because we don't have a second chance.